Assalamualaikum. So since I'm on birthday off, so we'll study via the YouTube. Okay, so feel free to forward or rewind at any point of time. Okay, so for this part, we are looking at page 122, which has the title velocity equation. Okay, so in the previous video we learned the vector form of the equation of line, or the parametric form of the equation of the line. So now we are moving on to velocity equation. Okay, so velocity equation means equation that involves speed in a way. Okay, first let's try to define it, because I didn't say velocity is speed, I said speed in a way. Okay, so let's try to define it. Okay, this is the velocity of an object is a vector quantity which needs to have both magnitude and direction. So basically velocity, why is it the same as speed? Is the rate of change of the displacement. Okay, so what does it mean is that if I'm moving at a particular speed this way, okay, so let's say the answer is 2, okay, I will say 2. But if I'm moving it this way, okay, and at the same pace, okay, I cannot write it as 2, I need to write it as -2 because I'm going at the opposite direction. So velocity, in velocity, right, the direction matters. Okay, the magnitude can still be 2, but the direction will change the parity. That means it can be either a plus or a minus, negative. Okay, so whereas for speed, okay, an object's speed is the measure of the distance covered in 1 unit of time. So you see, speed is actually the magnitude of the velocity. Okay, so that's the difference between speed and velocity. Okay, having understood that, we need to come up with the velocity equation. Okay, so if I may bring you back to a particular equation that we did earlier in the previous video, we actually came up with this OA, OB, and OC, and then we actually say that this is like 1 times of dA, 2 times of dA, and 3 times of dA. Okay, so I'm going to use that particular example, but I'm going to change the context. Okay, so let's imagine there's a particle here, can be a boat, can be anything, okay, but let's say there's a particle here that actually moves from D to A in 1 unit time. It can be 1 second, for instance, okay, or 1 minute, or 1 hour. Okay, so it actually moves this particular distance of dA, okay, in 1 unit time. Okay, so let's take the 1 unit time as seconds, so make it easier. So in 1 second, D can move to A in 1 second. Okay, and then for D to move to B, it will take 2 seconds, because earlier on we decided that we established that OB is equal to OD plus twice of dA. So it will take 2 seconds to travel to here and 3 seconds to travel to here. Okay, so what we have arrived at is that these numbers 1, let's say there's a 1 here, okay, 2 and 3, it tallies with the amount of time. That means 1 second, 2 seconds, and 3 seconds. Okay, so this 1, 2, and 3 can be replaced by time. Okay, how much time has passed. Okay, whereas the dA, right, okay, when I say that it can travel from D to A in 1 second, okay, you see, it can travel, for instance, if I say it can travel 10 meters in 1 second, 10 meters, okay, in 1 second, okay, it also means that I can travel 10 meters per second. But 10 meters per second is speed, okay, but because we are talking about direction, this is actually velocity. Okay, so what we have discovered is that the numbers here 1, 2, and 3 is actually the time, whereas the dA, okay, is actually the velocity. Okay, so in the book, I didn't follow exactly, but they came up with the equation right at the bottom of page 122. You'll see that you can write the equation R. Okay, is equals to R naught. So what is R naught? R naught is any point on the line. Okay, then after that you plus with R, and then with VT. Okay, so what is VT? V is the velocity. Okay, that means in this case it's the dA. Okay, and then T is the time. In this case it's the 1 second, 2 second, 3 seconds case. right? Okay, so this is what we call the velocity equation of a line. Okay, r is equals to r naught, a particular position vector over there. Okay, and then plus v being the velocity. Okay, t. Okay, v is also the direction vector. Okay, so it's actually the same as our vector equation of the equation of line, but we just put it into context and say that this is actually the velocity equation of a line. Right? Okay, so I'll continue example 12 in the next video. Okay, Assalamualaikum.